Okay, so now we're at site 3, and site 3 you can see looks a wee bit different. Yes, it's probably got wider. Has it got deeper? Well, there might be a few reasons why it might not. We want to test two things: the velocity getting faster and the bed load size getting smaller. But as you can see around this area here, there's a lot of really big boulders and things sitting around. In the 1960s, there was a landslide in the local area, and it's brought down this larger than expected material down into the river channel. That larger than expected material is making your bed load size become probably a bit higher than what you might expect, so that might help you explain bed load size anomaly going up. And if you've got lots of bed load inside your river channel and lots of water trying to get past it and get slowed down with friction, then you might also then get a slower velocity here. One thing making two anomalous results: larger bed load meaning slower water passage and larger than expected bed load size.
Here we are on slopes of Troston Mountain on our river study. As you can see in the background, we have a small river. We're in the upper course. We see in the river here large bed load, very angular. And what we're seeing here and looking at is the group here who did a fantastic job, but unfortunately they introduced a little bit of bias into their river study. Two examples here of what they're doing. This is an example of the type of rock you'll often find being picked when we're in the upper course. Why? Because it's easy to fit into your hand and pick up out of the river. This here, if I can even lift it, is the sort of rock we expect to see in the upper course. Angular, big, heavy and difficult to lift out. Therefore, very often in our river studies, we do not pick them out, and therefore we introduce bias into our river study.
Another issue with your readings that you take at site, your methods, particularly when you're evaluating them, you want to think, how accurate are your methods? You can see this group right now are doing their depth, but have a look at their measuring tape. It's sagging across the middle of the river, so that distance that they're measuring is actually going to work out longer than the actual width of the river. Is that an accurate result? No, not an accurate result. So we're going to evaluate that negatively. How could we do that better? Well, could we use maybe a laser to go across there and measure that more accurately? Or could you simply just hold it tight between the ranging poles? Two options for you to improve. With regards to your method for velocity, you'll see the girls here have got their tennis ball coming down this direction, and it's going to get stuck in the rocks. And inevitably, they're going to have to give that tennis ball a push along, which is a really poor scientific method. It's something that we shouldn't really do. So when we're writing up our results and we're thinking about things that we want to evaluate, so for an evaluation question, we want to say that our velocity, we had issues with the tennis ball or orange getting stuck, and we manipulated our results by pushing it along. So that's a big problem. Okay, we're at site 3 at the moment, and today it's really sunny. We're having a lovely day today, but we've had an anticyclone, and that means that we've had dry weather for about 2 weeks. There's been very little rainfall affecting the valley, so therefore, you can see from the girls here, they're only actually up to just their ankles at the moment in the river. The level in the river is really quite low. Now, one of the questions you might be asked on the GCSE paper is one of the ways you might extend your fieldwork. Well, at the moment we're actually finding at site 3 the depth hasn't increased particularly much from site 1. That doesn't really make sense because we went from the upper course down to the middle course. So if we did this fieldwork maybe in December, when the river's much more full of water from a very wet winter storm, well, this site would be much, much deeper, probably wider and flowing faster. So a way we could extend our fieldwork is that we would do it at a different time of year. We could also move to a different river to see if those geographical principles are true as well. We could go to a river closer to school, we could go off and look at the River Lagan or something like that. But we want to extend our fieldwork by doing a different time of year and a different river.